Let's wait for some seconds. Okay. Well, dzień dobry. Hopefully I said it correctly. First thing in this presentation is that I need a selfie picture because my daughter doesn't believe what I'm doing for a living, so I need a picture. Okay. You can even smile if you know how to do it. 1, 2, 3. Perfect. Thank you very much. So, let's start with this presentation that goes about code quality and why not in the AI era. I will try to do this presentation following a story about one monster, a hero, and some kinds of fights. Let's hope that you find it entertaining. So, I usually start my presentations trying to impact your brain with numbers. And, well, this is not my salary. It's basically the cost of poor quality code in United States only for 2022. But you could say, yeah, Jonathan, but I'm not concerned about my company's money. Sure, but then I can give you another metric, that it is 4 days per month on developer. And this is not our vacation time. It's the time that we spend on fixing, finding and fixing errors. So code quality is really impacting a lot our code bases. I'm Jonathan. I'm Java champion since 2020. I'm also one of the organizers of the Barcelona Java user group, and also co-founder of JBCN or DevBCN. It's a conference that we host in Barcelona every year. So if you don't have anything else to do in July, just think beach, paella, sangria, and technology. Okay. I come from Barcelona, where we have an amazing football team with one amazing Polish guy that it is the most score man in the league. So thank you, Lewandowski. But also we have a very nice woman in our female team. I think Eva Pajor is from Poland, right? So yeah, we have amazing Polish people in our teams. Well, I've been coding for more than 30 years. And I've used lots of languages. I started with Pascal, C, but I would say that the one that is deep in my heart is Delphi. I don't know, anybody has used Delphi before? Okay, great. You know what happened to me the other day? I received a job offer for a Delphi position. I assume somebody died or get retired. So, but nowadays, I work as developer advocate for Sonar. Anybody here that doesn't know what Sonar is? Okay, I can go home then. Okay, so Sonar basically is a company that it is behind SonarCube. It's the most famous tool that does static analysis on our code base. But we also have SonarLint, that it is a tool free for IDE. Who uses SonarLint here? Okay, after the talk, the rest can explain me why you are not using SonarLint. So we have SonarCube, that is a tool. It's free, you can download it, and it will cover more than 30 languages at the same time. So it's common to have Java, JavaScript, Kubernetes deployment files in the same project, and the tool will analyze them all. And also integrates with several DevOps platforms. And Sonar Cloud, that if you are using or having an open source project, keep in mind that Sonar Cloud is free for all open source projects. So most of the Apache Software Foundation projects are using Sonar Cloud, but others like Quarkus, Micronaut, and other projects. So if you're using a pet project or open source, think about using it. Okay, so the slides, this is the QR. You can just follow the slides as I'm talking or after the talk, as you prefer. At the end of the talk, there's already the QR. There's also the QR. So the agenda, basically I will try to explain what it is poor quality code. We've seen some numbers, but I will go further on that. I will show you, well, this is obvious, but let's remind which are our developer tasks daily, and we will put focus on some of them. Then, why not? Let's talk about generative AI focused on code, okay, using Copilot and other tools. Then I will show you the most detected issues using the telemetry of our tools. So when you use SonarLint, well, you can deactivate it, but usually you are going to send telemetry about which are the issues that your project is hitting and what are you doing with them. So it's like bypassing because I won't fix it or because it's a false positive, whatever. So I will show you which are the most detected issues in the projects out there, and I expect that some of them will impact your mind. Then I will show some interesting hints in order for you to try to follow the clean code approach. My point here is basically overwhelm you with all the hints that you should have in mind, that it's difficult to have them all in mind. That's why I will show you some tools that you can use in order to, and methodology in order to fulfill this clean code approach. So let's start with the monster of this presentation. And the monster is the poor quality project. Probably you can remember being part of one of those projects, or maybe you know someone that has been in one of those projects. So basically, those projects are hard to read, and we spend 90% of our time reading code, so only 10% of time coding. So definitely something that it is hard to read is going to impact a lot on our productivity. But it has a lot of bugs too. As we said, 4 days we invest every month to solve them. It's messy because we have everything coupled, and we don't have even the objects in their domain, so everything is scattered across the project. But it's also vulnerable. And just only focusing on the number of CVEs in 2023, it's 28,000. Lots and lots of them. So we need to have security in our mind because this costs a lot of money. Coupled, as I said, it's everything connected. So every time that you want to refactor something, you are going to touch a lot of things. And finally, it's inefficient because we are not using the languages and the libraries, latest versions featured. So maybe there are ways of doing it more effective. But we have a hero in this story. And surprisingly enough, this hero is every one of you. Who is not here a developer? Okay, so all of you are this one. And the task that you do usually every day, you focus on new features. Yes, because this is what we are paid for, usually. But you don't have enough time to fix step debt. Who thinks you have a lot of time to fix tech debt in your project? Who thinks, perfect. Who thinks you have so-so time to fix tech debt? That's impressive. And who thinks you don't have enough time to fix tech debt? Okay, so basically it's aligned to the bottom of the scale. So we spent also a lot of time fixing bugs. And finally, we also invest a lot of time reviewing code. And I'm putting like a highlight here, because with AI, we are introducing a new reviewer in your code, who is using you very often, Copilot and other tools, in order to generate code by AI. Okay, for all of you, you know that you are introducing a new reviewer. So because now you are reviewing the code that Copilot is generating, or at least you should be. Because you know what? When you do git blame, there's no Copilot there. It's your name, the one that appears in the git blame. So you are introducing a new reviewer in the code, hopefully. And this will mean that you rant a lot about old code, just up to the point when you discovered that it was you who introduced this code 1 month ago. And also, you learn. All this process is going to impact on you. Let me introduce here, let's say, an off-topic thing, because it's also part of my passion. And it's super important that you are here. Just only take a look of all your colleagues, all of your teammates, all the people that are in your company. How many of them are here? So you are lucky, and you should be very proud of being here. Don't stop going to conferences, to meetups. Who goes regularly to meetups? And what happens with the rest? Meetups are free. Meetups are a way of learn a lot and know a lot of people and increase your knowledge and your contacts. I can say that my professional life is completely different from the point that I started joining communities, dramatically. So I totally encourage you to go to meetups. You have lots of meetups in Poland and around Europe. Just go there, learn, speak, and network. That's it. Well, finish. So, but happily, and luckily, we have the helper nowadays. And the helper is, generative AI. The thing with generative AI is that we have lots of them. You can use Copilot, you can use Gemini or Tab9, Codium. You have lots of IDEs and plugins that are going to help you in order to generate code. And the scary thing is that we are kind of using around 10% of generative AI in our code, but it's estimated that we are going to use 70%, so 7 times more by 2027. I assume that as all of the estimations, the credit of this value is very low, but it's an estimation. But it's important that it is increasing our speed by 55%. That's interesting. But on the other side, when you ask Copilot, give me this method, blah, 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 apparently we are only accepting the answers on the 40% of the times. So there's a 60% of the times that Copilot is giving us an answer and we don't like it. This is one important metric. And another one is that juniors are using 20% more generative AI in order to generate code, more than seniors. This could be seen as like 2 different options. One is, yes, for easy tasks, generative AI is good, that's fine. So there's no problem on that. Or we could see this as juniors are more aligned to new technologies and trends, and they are using the generative AI. But the problem is, do you remember what I told you? That you are introducing a new reviewer when you are using generative AI. If the reviewer is the junior, then the quality can be not as we expect. So we need to think very carefully when we are using generative AI. It's not bad. I mean, it's a tool, and we need to know how to use it. Just only using the Copilot text when you use it, it says, make sure to verify any generated code. It's not me, it's Copilot who says that. Definitely we need to review the generated code by AI because, well, apparently, Copilot is only right in the 29% of the times. It's wrong in the 51% of the times and partially wrong 20% of the time. So it's an interesting data in order to accept or not accept what Copilot is generating. But ChatGPT, well, is way more correct. But I assume that it's also because it's used for broad or more general purpose rather than only for code. So it's important to know that code generated by AI has a lot of issues too. So if we take complex tasks, it's not that it's correct. It's that it's basically introducing issues in our code. So it is for hard tasks, it's introducing around 70% of the time. It's introducing issues. For easy tasks, it's half-half. So it's not that it is correct, but it is also that it is bad for our project. It introduces issues like, well, reassigning parameters, what can go wrong if we reassign a parameter, or, I don't know, things related to visibility and maintainability. These are not particularly critical things, but are also impacting readability. But we also have compilation and runtime errors, null references, undefined variables, duplicate variables, and divisions by zero. So it is introducing a lot of issues on compilation time and runtime. Definitely, we need to review this code. I did an example, and I said, OK, Copilot, generate a method that iterates a collection, doing the sum of its integer value and calculating the average. It's easy, right? And Copilot gives me this code using a loop. Anybody can tell me a better solution for this? Sure. And OK, perfect. So this code is from Copilot. This code, well, I created it manually. It is using streams. It is using a collector called thing. This collector, I think it comes from Java 12, if I'm not wrong. Thing accepts 3 arguments. First function, second function, and a function that will be executed with the result of those 2 functions. So with this line, we have the same as this code. And if you don't have this plugin, this is a plugin called Cognitive Complexity. And it calculates, well, the complexity. I will explain what it is, cognitive complexity. So this code has a cognitive complexity of 12%. But the one that I created manually has a cognitive complexity of 0. So in this case, apparently, Copilot doesn't know a feature that was introduced years ago. Sure, explain it. Yeah, OK. OK, good point. OK, thank you. So it's introducing a bad approach, and also it has issues. So if you had created this with Copilot, you can review this and detect that. But for other people that do not detect that, they are simply committing the code. They are putting a wrong approach and also introducing errors. So, yeah. And to be honest, I think it took me way longer to do all of this than to do this manually. If you know the language features, just use them. Don't rely on Copilot. I did another example. generate a method with multi-threading, accessing a URL, whatever, and parsing the response finding at 200. This is just only connecting to a URL several times in a multi-thread approach. Copilot, okay, created a platform thread. But why? Java 21 already has virtual threads, right? So why not to use virtual threads instead of platform threads to connect to a URL? This is especially done for this. So Copilot is not even using the latest features, and Java 21, it's months ago. So again, relying on Copilot is not going to generate the best code. And thanks to you, your name? Eugen. And thanks to Eugen, it's not using the right approach and also introducing issues in the code. Better to use a virtual thread. So the challenges with AI code generation, as we've seen, quality and reliability. Maintainability, because it's hard to read, because we haven't created it. It's another person that has created it. So we need to review it, and another person, we expect them to read it and understand it. My CEO was telling me that he had a meeting with a big company, and they had a very big issue. And when they found the Git blame, who was the developer, they asked, okay, why you introduced this issue? And the answer was, hey, it's not my code. It's Copilot's code. But that's not acceptable, because Git blame is pointing to you. So if we don't review with our brain and with tooling, we are going to introduce a lot of issues in our code. We can introduce technical debt because it is not using the latest versions or the latest features of each release, or in this case, Java version. And we are losing control. So we are creating code without controlling the generation of that code. We have a process in our brain in order to create code. We are relying on an external tool to do all that process. And we just simply reviewing and putting more or less effort on that review. So we are losing control of the code that we are introducing. In some cases, even Copilot can introduce bad algorithms in order to encrypt things. And yeah, we are also opening the door for vulnerabilities. So how can we deal with generative AI? So we need to treat generative AI, so all those Copilot, GitHub, Tab9s, Gemini, whatever, tools, as an intern. So everything that intern is producing, we are going to review it, we are going to understand it, and we are going to challenge it. The three things. Because we cannot accept code that we don't understand and that we are not sure that it is secure and performant. And usually as a starting point, instead of just generating full solutions, is simply using Copilot to generate, okay, let's generate an API for this. Okay, it will create, I always do the same error. I don't know if Copilot is a he or is a she. I don't know. Well, in any case, we are relying on it in order to generate code, but it's not critical. It will help us to evolve from that. And constantly, and I expect that this is, if you have to have one takeaway from this presentation, I think it has to be this one: review, review, and review, and review all the code generated by AI. But our hero in this story, so you, in order to, let's say, kill the poor quality monster project, you need to know if is it bad? Is it that bad? So I mean, are projects that bad out there? Because we could think, okay, maybe we are having very good projects with some issues, minor issues. This is the common use case. it's not. So based on the telemetry that we have, it's like several thousands of projects, and we have like 1,800 million issues detected. From those, the top 10 that I'm going to show you are more than 500 million issues in the projects that we analyze. And the most detected issues are the cognitive complexity is too high. I will show you and explain you what it is, cognitive complexity. We have a lot of dead code in our projects, but I always see the dead code as a big problem. We don't know if the dead code is the code that we need to remove, or if the dead code is there because we need to create the code that is using the dead code. So we don't know exactly which is the problem. It's easy, just remove it, or it's more complex, we need to develop that feature. We have local variables, function parameters, private fields, private methods, imports, that's a classic, and commented out code. The same, when we have a commented out code, the right thing to do is remove that comment or to implement the code. So we never know, and it's going to introduce uncertainty in your project. A lot of to-do tags everywhere. And I always explain this, this situation. There's a famous Apache Software Foundation project. I will leave the name out. That has a to-do tag in a part of the code that has more than 10 years. So I assume that one day, someone will either remove the to-do or implement the code. So that's not the way to do. And we have also in Java projects, raw types used instead of, so when we are using collections, we are not specifying the type, so we are running the risk of some breaks in runtime. And string literals duplicated, instead of that, we should use constants. It's easy to refactor. And generic exceptions instead of specific exceptions that it's easy for the consumer to know what happened. Yeah, and the classic is a reference to null that we will experience in runtime. So we have like these groups: complexity, dead and useless code, comments, design, error, and null handling. These are kind of the detected issues, but we also have security issues. And the most detected ones is they are not using a secure password. So they are creating passwords inside the project using old or easy to break algorithms. So we should update which are the algorithms created to create those passwords. We are experiencing from execution inside XML parsers because we are not checking the XML that it is being passed. Endpoints are vulnerable to cross-site scripting. Credentials hard-coded. Why not? A lot of projects have the credentials hard-coded. If I ask every one of you, do you think a project should have credentials hard-coded? I can assume that 99.99% of you will say no. But the reality is different. Sometimes we start creating a test, we put the credential there, we evolve, and we forget. And if we don't touch that code again, nobody will review that code. So it can be easy to miss credentials, to leave credentials hard-coded, because it's an evolution, not because you wanted to leave credentials hard-coded. And also, in some cases, you can be vulnerable to path injection attacks if you are using a parameter coming from the user in order to go to a file. So you should check also which are the paths that are allowed. So credentials and injection, basically. Let's go to give some hints to our hero in order to fight this monster, basically. Let's start with vulnerability. I don't know if anybody of you has ever experienced this. I don't know if it's a meme, if it's reality, or just a joke. But I don't know. One day I will need to experiment this. Okay, so basically, we will start with SQL injections. So in this case, we are using I would say the old way or usual way to create queries using a string concatenation. With this, we can inject SQL, and then an attacker could just simply bypass the check. So the problem is that basically user equals to single quote and the value could be one single quote and dash dash to comment the rest. So in this case, we are bypassing the check on the password. The way of doing this is obviously to use parameters instead of a string concatenation. So in this case, we are using 2 parameters, and the attacker cannot just simply bypass by putting a wrong SQL in the user. HTTP redirections. If we are using a URL coming from the user, instead of just happily doing the redirect, why not? Because we rely on our front end. Our front end is going to check the wrong values. No. What we need to do is just simply have an allowed list of destinations. So we need to sanitize all the values coming from the user. We can have a discussion about this because, yeah, the world is divided into 2, basically. So, usually, people using ORMs, I assume most of you, who is not using ORMs? Hibernate or great. For the rest, usually people create the entity that represents the table. Okay, fine. And they use it also as the DTO in order to send values to the client and also to accept values from the client. So we are using the entity for everything. The problem with this is that we need to sanitize the entity coming from the user. This is one point, because the user could send values on fields that we don't expect a value. And then if we just simply save the entity, we are running the risk of putting wrong values or harmful values in the database. So the way to go, well, that's also another even greater problem that it is nowadays. Some ORMs allow you to annotate them, and internally you have an entity and you are going to have a REST endpoint created directly from the processor, directly from the entity. Then, so you are you have a big problem with that. So instead of using the entity, go to the world of DTOs. So the entity is a representation of your database. Fine, I agree on that. But the thing stops there. What the user needs is the representation of what the user needs, not the entity. So create a DTO for every endpoint, considering the real fields, values that the user needs. Even it doesn't have to be one-to-one. You can have one field in the DTO that represents 10 fields in the entity, or 10 fields in the entity that represents 0 fields in the DTO. So instead of using entities for everything, just use entities only for the database and use DTOs in order to communicate between different layers or the client. There are tools like MapStruct that are very useful in order to do the mapping between DTOs. So you can use it in order to map from the DTO to the entity. Let's continue with more bugs. So if you're using Java, the old way is to create resources and do their handling manually. So you create them, you release them. Here we have an example where we are creating resources, but we are only releasing or closing one. because we have a loop. And then in the finally, we are closing that variable, but we are only closing the last one. So we are leaving a lot of resources open. So instead of using that, just use try with resources from Java. So for that, you are doing the try, and you are creating the resource. It will be Java who releases all the resources at the end of the try. With design, let's see, cognitive complexity too high. Who knows what it is cognitive complexity in comparison with cyclomatic complexity? Okay, so for all of you that do not know what it is, cognitive complexity, I did not know before joining Sonar. So we have this method. Let's put it that way. I don't know what it is doing, but it has a cyclomatic complexity of 5. But we have this other part that also has a cyclomatic complexity of 5. I think that this part is way easier to understand what it is doing. Who agrees with me? Okay. So we know that this cyclomatic complexity of 5 is not giving us a number in order to decide which part I'm going to refactor. But we have cognitive complexity. And for the same left part, now we are considering breaks and indentation. And for that, we have now a cognitive complexity of 9. And for the right part, now we only have a cognitive complexity of 1. So now we know for sure that this is not the part that we need to focus in order to refactor. So instead of using cyclomatic complexity, use cognitive complexity. There's a plugin for IntelliJ that will calculate the cognitive complexity for every method. So you can use it, it's for free, and then it will help you in order to put your code more readable. Or use tools. I will show you later. But for Java versions specifics, here, who is not a Java developer? Okay, maybe you will find similarities, but obviously not according to the Java version and so on, but probably depending on the language that you're using. So instead of using the classical switch, that we need to put the breaks, and if we miss one break, we are messing with everything. Instead of that, use switch expressions, where we put all the values in the same line, and this is a function. So we don't even need intermediate assignments. So this returns a value. So it's way easier to understand this part. With the stream to list from Java 16, the problem was, well, one of the most important parts when we are developing is that we should focus on immutability, because mutability brings uncertainty and brings issues with testing. So before Java 16, when we were iterating a collection, we were returning another list with the collector, but the thing is that this toList is returning a mutable list. So you can get that list and mutate it. That's not what we expect. So before Java 16, we had the toUnmodifiable list, and then this returns an unmodifiable list. But this is too verbose. So Java 16 brought a toList directly from the stream. And this returns an unmodifiable list. So it's easier and more consistent across all the code. If we still want to have a modifiable list, then we still have the collectors to list. But the way to go is to use the toList from the stream every time that we can. Records. So from Java 16, instead of having super verbose classes and deal with mutability, use records. records are providing the same, so all the methods, and they are final. They are not mutable because they are not providing setters. So you need to pass all the values on the constructor. It's the way to go if you can. With Java 21, yeah, we know that we can use virtual threads, but don't use virtual threads for everything. So if you have a synchronized code called by your thread, don't use a virtual thread. Use a platform thread. But it's important that somebody checks that, and it's easy to miss and not spot this line. So again, you need something that warns you when you are introducing this kind of issues. With Java 21 also, in order to increase the readability, instead of having a switch case and a conditional inside the case, in this case we have, if the object is a string and the length of that string is greater than 80, do this. This is too verbose. Instead of doing this, use the case when. It's easier to read, and it's more consistent. And it's the way suggested by Java, from Java 21. But now let's focus on the tools that we can use in order to do all this. I expect that at this point you are overwhelmed. It's like, I'm tired of seeing issues, issues, and issues. Yes, I know what it is. But for that, we have some weapons that are going to start from the code. Then we are going to have some tools in the IDE. Is here anyone using an IDE that is not IntelliJ or VS Code? Which one? Okay, interesting. Nice. Nobody using NetBeans? Okay. Okay. I used it for a long time. Okay, so we have tools in our IDE and then in CI/CD. So this is more like the developer focused, and this is more like company focused. So this is going to check for bugs, vulnerabilities, and also important best practices. As we've seen, the things that we saw for Java 21 are not kind of bugs, but are best practices. It's important to use those best practices, but it's hard to cope with all the versions. Now with Java, every 3-6 months, we have versions. We have LTSs in 2 years. So it's like, it's a fast pace, and it's hard to cope with all of this. But we have static analyzers that are going to check all our code. How do they work? So basically, static analyzers can focus on source code and on bytecode. Usually, source code. They are going to create the abstract tree, and they are going to check the abstract tree from different points of view, from the semantic check, control flow graph, symbolic execution, and others. There are a lot of plugins that those tools are using in order to check the code. And they are going to detect all those issues. For some issues, you need to follow the flow of your code in order to see if a variable has been used or can be a null pointer or something. So there are different plugins. And these tools are creating this tree that identifies every part and every element of the code. And with this, they are going to check all of them. They are going to, if you are running them on the IDE, they are going to check your code and warn you about the hints. You are going to have the list of issues. But the important part here is that you are going to learn why they are issues and how to solve them. It's important to put focus on this because the important part is that you learn and you don't always rely on the tool in order to fix the issues. But for the CI/CD, we have the quality gates that are going to ensure that you are not going to merge bad code into the main branch. And you can configure them in order to allow a number of bugs, a number of the number of coverage, and so on. So this tool is also important in order to ensure the code. In our case, Sonar has more than 35 languages now, and you can go to rules.sonarsource.com and you will find all the rules for all the languages. This is also a way to learn how to be a better developer if you know all the issues and you learn from them. As I said, we covered different languages, and we have a lot of rules for each one of them. Even for infrastructure as code, because we also check Kubernetes, Docker, Terraform, and so on. So we have in total more than 5,000 rules and 35 languages. I'm running out of time, but let's go quick here. The methodology. So basically, the code is like everything live on Earth. Code also dies. So only 30% of the code remains after 5 years. So more or less, it's 20% of the code that is being touched every year. In this case, we see this project where the code introduced in 2010 no longer exists in 2022, but the same with 2016, almost half or a fraction of it. And this is the same for most of the projects. You can check the Git of Theseus. Well, it's in the references at the end of the presentation. So if the code changes 20% of it every year, what's the point of focusing on old code? So the point is to focus only on new code. In tools like Sonar, we have the overall code, where we see all the issues for our whole project, 1,600. But the point is not focusing on this. The point is focusing on the new code tab. So you define what's new code for you, and you are going to keep a 0 level for all your new code. And eventually, your whole project will be clean. So code quality, we are going to be make the project more readable and intentional, reducing the cognitive complexity, reliable because we are going to also, important, create tests. And we are going to also be secure using deeper SAST, that it is checking also the security on the libraries that you are using. This is also important. Modular, in order to evolve some modules without touching the whole project. And efficient, because in the end you are using the language features and the library's best practices. This is also a very important point. Just to wrap up, the takeaways of this presentation, basically that code quality and security are super important, but there are lots of rules to consider. We've seen a big number. Gen AI is great, but you need revision. You need to review it constantly. And tools will help us in order to check for all this code from the IDE to the CI/CD pipeline. And to focus on the new code, because around 20% of the code is changing every year. This is being the presentation. I ran out of time, so my apologies for this. I hope you enjoyed. Thank you very much. And here you have the QRs for the slides and the feedback, please, and also the article that covers the presentation. Thank you very much.